Today we are going to be going over how to find the multiple representations using a scenario, equation, table, and graph. So today we're going to be talking about Holly. Holly is driving 55 miles per hour, and we want to set up an equation to figure out how far she can go in X number of hours. Meaning, given any number of hours that she drives, how far is she going to get? So the first thing we need to do is set up our equation. So the information shown on the screen shows that we have 55 miles per hour times however many hours she drives to get a certain distance. So we're going to put that as 55, and we're going to use the variable of x equals y, the distance she's going to travel. Once we do that, we now have our equation that will help guide us through. Now, when we do a table, this is our equation we wrote on the previous page. The 55x is our process. Now, some boys and girls are getting confused and they're saying that it's 55 times. Yes, it is 55 times something. So if you look at this table, it shows you right here that x is something we can change into any number. And so in the first one, it is 55 times 1. We are replacing the x with the first number. This is a process table. You should be familiar with this from a previous lesson in 6th grade. So we're going to use the values of x, substitute them in as we've done in the past, and find the value of y. So x we put in, it's our independent. Y changes because it depends on the x. So if we do 55 times 1, we get 55. We're going to repeat this process for the next one. So our process is 55x. So 55 parentheses. We're going to replace x with 2, continue down our table, 3. Now, if you look at our input-output table, this is going to change to the number 6. We have to use whatever variable value is given to us in the x column, and our last one is going to be 55 times 10. Now we'll go through and we'll complete the value of y. So 55 times 2 is 110. 55 times 3 is 165. Now, along the y, so far we could count by 55s. However, now that we're going to do 6, we cannot just simply count by 55s. We have to work that out. And 55 times 6 would be 330. And then the final one at the bottom is 55 times 10. That would be 550. So each of these is how far she can go in this many hours. So if Holly drives 3 hours, she is going to drive 165 miles. So we have now gone from an equation to a table. The next one is to take that equation and we are going to graph it. Now, this particular graph is actually going to be done for us, but before we look at the information on it, we are going to talk about the components. We have down at the bottom, h being the time, and x, and y is the miles. Now in this case, they did use the letter h. We were using the letter x. The variable doesn't matter as long as you're consistent across the problem. So if we move our table here, our box off of our table, we can see that our line that is plotted has the points that we used from our previous table. So we have 155, we have 6 hours is 330. So each of the points that we calculated on the previous screen is here. So when you look at this particular graph, we see that if she drove no hours at all, she's going to drive no miles. So it goes through the origin. So this is a constant rate of change because it's 0, 0 to start with. Anything that goes through 0, 0 is going to be a proportional relationship, and that's something we're going to continue talking about for several weeks in 7th grade. Once again, the way we were able to match this is we could say any of our information from that table on the previous page matches this table, or this graph, sorry. So we have 155 is an ordered pair. We have 2, 110. So we're able to match them in that manner. The last piece that we're going to do is we're going to actually see this in a different situation. This particular problem is saying that they want us to take the number 325 and find out which one of the following is a constant rate of that, meaning we take our x and we multiply it by 325 to get its output. So I've gone ahead and filled in our table according to what they have on top. Our x is going to be the 1, 3, 5, and 7, and our process is going to be multiplying it by 325. So 325 times 1 is going to be 325. All of these seem to be correct in that form, so then I'm going to go to 3 times 3 times 325. That's going to be 975. So I go through, that one's correct, that one's correct. Oh, that one's not correct, and that one's not correct. So I'm now able to eliminate some of these based on that incorrect answer. So I'm going to go to my next one. I'm going to do 325 times 5. That is going to be 1625. You can't see my 6. 1625. So when I look, that one's incorrect. That one's okay. That one's okay, and that one is incorrect. So that means I'm going to have to do 325 times 7, and 325 times 7 is going to be 2275. And when I look at my last column, 2275, this one's not right, that one's not right, and that one's not right. By going through the process of comparing tables, we're able to find the correct match. Our last one that we're going to do is we're going to actually find the constant rate from this graph. This particular graph, the way to do it is we want to find two nice clean points. So I see right here that I have 2, 1. If I come over to this one, I'm going to have 4, 2, 6, 3, and 4, 8, 4. You want to have at least 4 points so that way you have a good grasp of what's happening. Now, I have to look, what do we do to x to get to y? I am noticing that the numbers are going smaller. Since from left to right, they are going smaller. And this goes through the origin of 0, 0. It means we have to be dividing. Because if I were to add or subtract, it would not necessarily go through the origin. So if I start with 2, for example, and I were to subtract 1 to get 1, I would have to do that same process for minus 1. And 4 minus 1 is 3. That does not work for getting that 2 in the column. So then we do division. What can we divide 2 by to get to 1? Well, we can do 2 divided by 2. So I'm going to do 2 divided by 2 equals 1. What is 4 divided by 2? Well, that gives me 2. So far, so good. 6 divided by 2? Oh, that gives us 3. So the process is we're going to divide by 2. So we have 2 divided by 2, 4 divided by 2, 6 divided by 2, and 8 divided by 2. And those are all true statements. Now, when we look at this answer choices, divide by 2 is not a choice. But dividing by 2, as you can see in those fraction setups that I put in the middle, are the same as, if I do 2 divided by 2, is the same as a fraction, and a fraction is the same as a decimal. So if I put 0.5, if I write that as a fraction, that fraction is going to be 1/2. And I were to take our graph and go back, right here we have 1, and if I divide 1 by 2, which is what we're dividing by in the middle column, dividing by 2, 1 divided by 2 is half, so our process is 0.5. You're going to continue this activity on your own by completing the activity in the assessment component in Schoology now.